Hey everybody, for today's video I'm going to just give a couple things that I want to mention, and then I'm going to go through and take you through the probability worksheet assignment. So that's my plan for right now. I guess a couple quick announcements. We are getting close to the end of the chapter. Hopefully you've been paying attention to that. I will be posting the review assignment so that you'll be able to take a look at that this weekend. On Monday, we'll be able to take a look at some things. If there's any questions, I'll be able to go through them at that time. Otherwise, we'll plan on the test showing up on Tuesday. That'll be a Schoology test. That'll work pretty much the same way as the Schoology test went when we were still together. It's just that you'll be taking it in your house instead of in my classroom. So should be pretty somewhat normal for you guys to get through that. But I'll talk more about that on Monday. In the meantime, for today, I am going to switch over to the assignment. Most of you have turned this in already, but I thought instead of just posting an answer key, I would show you me making the answer key, and I'll talk through it, so in case there's any questions, you'll be able to get them answered. So question number 1 is a probability question. Instead of areas, we're just looking at a length, but we've got the 3 lengths on the diagram. So if it says, what's the probability that the point is on segment XZ? Segment XZ we see is here. It's got a length of 5 plus 3 or 8, and that's 8 out of the total. 2 plus 5 plus 3 is 10, and so our probability is 8 out of 10, which would be the same thing as 0.8, and that would be 80%. The next one, the point is on WY. WY is that segment there with a length of 7, and the total length of the segment is still 10, so it's 7 out of 10, or 70%. And then finally, the probability that the point is not on YZ. Well, if YZ is over here, that's 3. The rest of it, this is not on YZ. This is 2 plus 5 or 7. So this one will be 7/10 as well. For the area problems, like we've got over here, find the probability of throwing a dart and having it land in one of the shaded regions. We've got the shaded regions are triangles, and so it's basically the area of the triangles divided by the area of the whole thing. So to find the area of the triangles, a couple ways of doing this. One way that we could do this would be to actually find the areas of the triangles. This triangle right here has a base of 2. We see that from the diagram. And a height, we're not sure what the height is right away, but we see that this total distance is 12. And this distance here is 8, so we can do 12, take away that 8 to find that this little segment right there is 4. So this triangle has an area of 4 times 2 divided by 2. Remember, base times height divided by 2 is the formula for the area of a triangle. And then this triangle over here, same idea. If this length is 2 and the whole length is 6, that means this base is a length of 4, 6 minus 2. And then we know that this height is 8 because that was given on the diagram. So this triangle is 4 times 8. Divided by 2. Again, base times height divided by 2. That's 16. 4 times 2 divided by 2. 8 divided by 2 is 4. So one way to find the area of the triangles is saying 4 plus 16. Add those both together. Another way that we could do this would be to find the area of the whole big triangle and then take away the area of that rectangle. So I could do 6 times 12 divided by 2, and then take away 8 times 2 for the area of that rectangle. Either way we do this, we're going to get an area of 20, whether it's 4 plus 16, or let's see, this would be 36 minus 16, that'll give us 20 also. And then the area of the entire triangle, call this the area of the big, or the area of the whole triangle. Like I said already, that's base times height divided by 2. 6 times 12 divided by 2 is 36. So our final probability will be the probability of being in the triangles. That was 20. Divided by the whole area is 36. And 20 divided by 36, when I put that into my calculator, I got about 55.56%. Or about 56%. And then the dartboard problem, similar to the problem that I had in the notes yesterday. I've got a whole bunch of rings in this dartboard. In this case, it's asking me for first the areas, the area of circle A, circle D. Circle A is just this bullseye region. Circle D is the whole thing. That'll be important for the denominator in our probability fraction. And then the B ring and the C ring, well, let's talk about those when we get to them. Circle A is a circle with the radius of 3, and so the area is pi times the radius squared. That'd be pi times 3 squared. When I plugged that into my calculator, I got about 28.27 square centimeters. Circle D is the whole dartboard. Well, this radius is 3 plus 3 plus 3 plus 3. That is 12. So my area is pi times 12 squared. And when I plug that in my calculator, I got an area of 452.39 square centimeters. The B ring, now it's not the whole area of this entire circle. I just want the area of this ring of the circle. So I'm going to find the area of this circle with the radius of 6, and then I'll take away the area of the little circle on the inside. So pi times 6 squared for the whole thing, and then minus pi times 3 squared to take away that part. That'll leave us with just this circular ring on the inside. So that'll be pi times 6 squared, the big circle, minus pi times 3 squared, the smaller circle on the inside, leaving us with that donut shape. When I plugged that into my calculator told me it was 84.82 square centimeters. And then similar for ring C, I'll have to take this big circle with an area of, a radius of 3 plus 3 plus 3, a radius of 9, and then take away the B circle with the radius of 6. So let's see, we've got an area that is pi times 9 squared minus pi times 6 squared, which turned out to be about 141.57 square centimeters. Now this was all just area. Find the area of these sections. Now we go down here and it's asking me for the probability of landing in these different regions. But all three of these are going to be the same. The area of the region of interest divided by the whole area. And so for here, the area of the bullseye was 28.27 divided by 452.39, which was about 6.27%. Of course, plug that in your calculator. I'm not doing that by hand. I'm plugging that in my calculator to find out. The area of the B ring, I found that was 84.82 divided by the whole thing, 452.39, and that's about 18.75%. A little bit bigger probability there. And then finally the C ring, the area of the C ring was 141.37 divided by the whole area, 452.39, and that is approximately 31.25%. The probability of landing in the C ring is bigger than the probability of landing in the B ring, which, if you've played darts, you know it's easier to get a double than it is a triple because of the size of the regions. But there we go. That is assignment. Hopefully you can get done with that one if you haven't already, and then you can change gears and take a look at the review assignment. I'll get that posted for you guys so you can work on that this weekend. Get a good start on that this weekend, and then on Monday we can make sure I answer any questions that you have over that review assignment or anything we've done in this chapter, and then we'll be ready for the test. It'll be a Schoology test that I will have ready for you guys to take on Tuesday. So there's our plan for the start of next week. Hopefully this week went okay for you. As always, get back to me if you have any questions on the Schoology Hangout. ask me a question through email or however you're comfortable asking me questions. But I will see you virtually next week, I suppose. Have a good night. Bye-bye.